For thousands of years, blue was more than just a color. It was the color of the sky, the Nile, the afterlife, and eternity itself. But in ancient Egypt, blue wasn't simply found. It was engineered. Long before modern chemistry existed, ancient Egyptian artisans created something no other civilization had achieved at the time, the world's first synthetic pigment. Today, we call it Egyptian blue, and for centuries, its recipe vanished from human knowledge. So how did an ancient civilization invent a color that later generations forgot how to make?
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Let's go back more than 4,000 years. In ancient Egypt, blue symbolized rebirth, divinity, and protection. You see it everywhere, on temple walls, statues, amulets, even inside tombs. But natural blue pigments were rare and expensive. Stones like lapis lazuli had to be imported from thousands of kilometers away. Instead of depending on nature, Egyptian craftsmen did something revolutionary. They made blue themselves. By heating a precise mixture of quartz sand, limestone, copper compounds, and alkaline minerals to extremely high temperatures, around 850 to 1,000 degrees Celsius. They produced a bright, stable blue material. Chemically, this pigment is known as calcium copper silicate. This wasn't an accident. It was controlled, repeatable technology. In other words, Egyptian blue was not paint in the modern sense. It was a man-made crystal, and it worked beautifully. The pigment was ground into powder, mixed with binders, and applied to art and architecture. Unlike many organic dyes, it didn't fade easily. Some examples still glow with color after millennia of burial. But then, something strange happened. After the Roman period, knowledge of how to make Egyptian blue slowly disappeared. Workshops closed. Trade routes changed. Artistic traditions shifted. By the Middle Ages, the technology was gone. Artists across Europe and the Middle East admired ancient blue artifacts, but no one knew how they were made. The color had become a mystery. For centuries, scholars guessed. Some thought it was crushed gemstones. Others believed it was dyed glass. But no one could reproduce it exactly. That is, until modern science stepped in. In the 19th and 20th centuries, chemists and archaeologists began analyzing ancient samples using advanced tools, X-ray diffraction, electron microscopy, and later, infrared imaging. What they discovered was astonishing. Egyptian blue doesn't just reflect visible blue light. It emits near-infrared light, invisible to the human eye. This means that when illuminated in certain ways, ancient blue pigments literally glow in the dark under scientific cameras. This property allows researchers to detect traces of Egyptian blue even when it's no longer visible to the naked eye. Lost paintings, faded murals, erased decorations. Suddenly, ancient art began reappearing. But the story doesn't stop in the past. Today, scientists are studying Egyptian blue for modern applications. Its infrared luminescence is being explored for use in medical imaging, security inks, telecommunications, and even solar energy research. A pigment invented for gods and tombs, now inspiring future technology. Think about that for a moment. An ancient civilization, without modern instruments, without atomic theory, created a material so advanced that it still surprises scientists today. Egyptian blue reminds us that human innovation didn't begin in laboratories. It began with observation, experimentation, and imagination. A lost color, a forgotten recipe, and a blue that refuses to fade, even after 4,000 years. Sometimes, the future of science is hidden deep in the past.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.